Good day, viewers. You are welcome back to Tindanious Maths and Science Tutorials. Today we are going to end the business on domain and range of piecewise defined functions. Okay. Now, let's say if you have a function of say f of x, okay, which is equal to 1 over x, and I want to find for the domain of the function, okay, good. In other words, I want the set of values, okay, that will make this function defined, okay. So what we'll do is, we don't want the denominator to be equal to 0. If this denominator is equal to 0, what happens to the whole function? It becomes what? Undefined, right? So the domain should be, so we know that x shouldn't be equal to what? 0. Is that also in order to make the function defined? So therefore, the domain of this function f of x is such that x belongs to what? All set of real numbers, okay, except 0. Is that also? Yes. So in these tutorials, we are going to learn the various or other ways we can write the domain of the function. Alright, good. So if you can say that x is such that x belongs to all set of what? Reals, okay, where x is not equal to 0, you can also write it this way, which means we can include all values, okay, any possible values for x. But remember, you can't put x is equal to 0 here. When you set 0 there, the function becomes what? Undefined. So therefore, another way you can write this is x is such that, right, x belongs to all set of reals, okay, where 0 is not included. In other words, the minus 0, see this 0 is being put into braces or curly brackets, which simply tells us that 0 is not what? It's not considered. You get that? So it belongs to all set of real numbers except what? 0. That's what it means. So just in case you encounter this anywhere, don't be ignorant. Don't be naive. So far as Tindanious Science and Maths YouTube is concerned, we are going to explore. We are going to learn a lot. So hit up the bell button to receive all updates concerning my videos. So this is another way we can write the domain. So in this tutorials, let me consider this. All right, good. So we have determined the domain and range of the function f of x, where f of x is given by this, right? Good. Now viewers, you can write domain and range offhand, okay? When you do it for so long, you can write them offhand, but it is always advisable to graph them, and that explains why I did thorough videos or tutorials on the graph of piecewise functions. So viewers, if you are here, just visit my previous lecture videos on graph of piecewise function. I have graph of piecewise function 1, graph of piecewise functions 2, graph of piecewise functions 3, and graph of piecewise functions 4. So viewers, do justice. So let's go straight to the point. You have this. So let's graph the function. We have f of x, which is equal to, we have 6, right? So if I have my Cartesian coordinate system this way, okay? Now, let's say I have 2, 4, 6, let's say 8 here, right? I have -2, -4, -6. -2, -4, 2, 4. This is my y-axis, this is my x-axis. We have 6 here, right? So where can I locate 6? Here, right? So let me just draw this, my straight line. Remember, this is called constant function. So this is how constant function goes, okay? Just draw your horizontal line straight, right? Good. Now let's consider -4. Where is -4 here, right? Again, this is a constant function, so I have my -4 this way. As simple as that, right? Now, let's consider the restrictions, right? Good. So we are saying 6, right? But at 6, what's happening? X should be less than 0. So this is my 6. Is that also where is 0? This is my 0. So 0 falls here, right? Is that also good? So therefore, will I consider this portion or this section of the graph or this side? X is pointing towards this side. Look at the position of the arrow. This side, is that also good? So at 0, right? I'm also going to point at this side. As a result of that, I don't need this section of my graph, since this arrow is pointing towards the negative values, right? So my target is here. So I can just do this. This is my open circle, okay? Open circle at this point. Then I just draw my line this way, as simple as that. What about this? -4. This is my -4, right? X is greater than 0. See the arrow, you see this inequality sign is pointing towards this side. So that means I don't need this side, right? So I'm going to discard this portion. I have -4, then this side, right? So I'll open this. This is an open circle, then it takes this form. As simple as that, right? Good. So what do we do now? What do we do now? I opened here. This is called this is called an open circle. An open circle simply means that point is not inclusive. This is also open at this point, which simply means that point is not inclusive. Remember this. I've treated this into details for my previous lecture videos, right? Good. So that means all values, okay, over this side, okay, all the values towards this side, okay, is defined. Is that also? And this one, all the values at this side also makes this function what? Defined. That's the domain. But remember, we are not including what? 0 is not included. That is why at this point, this is what? Open. Remember, S is what? Is less than 0. We didn't include 0. That means 0 shouldn't be included. Because at S is equal to 0 to make this function undefined. This one to say S should be greater than 0. So that means at X is equal to 0, our function will also become undefined. So therefore, the domain of this function is what? A set of what? All real numbers, whether positive numbers or what? And negative numbers. Remember, except what? 0. So what do I do? Minus what? Then I have what? My 0. As simple as that. Now let's account for the range. Let's account for the range, which is very, very simple, okay? So you know that for points, okay, if you want to write coordinates, right? The coordinate of a point is given by this. X, comma what, comma f of x. Don't be confused here, all right? Remember, when you have f of x to be equal to your function, you say what? Let f of x be equal to what? Y. So I have what? X, comma, wherever I say f of x, it goes to what? Y. Is that also good? So if that is the case, here, at this point, what do I have? I have, this point is what? Is 6, right? So I have, this is 0. 0 comma what? 0 comma 6. Is that also? Now here too, let's plot. Let's write down the coordinates. This is also what? 0, then what? Negative what? 4. Is that also good? Now, for the range, remember, for the range we are interested in the y coordinates or the y values. But for domain, we are interested in what? In the x values. Is that also? Now, so that means we are going to pick this and pick that. Remember that. So the range of this is simply, now when you consider positive and negative values, which one comes first? This is the negative values, right? So if you have the number line this way, you have your negative values here, you have what your positive values here, right? So we come from the negative then to the positive values, right? Good. So the range here will be what? So 6 and negative 4, which one is lesser than the other? It's negative 4. So therefore I will start from negative 4. So I have what? I have my negative 4, then I have what? 6. As simple as that. This is the range of f of x. So viewers, let's tackle this side, this question. Now, I said determine the range of piecewise defined function from the graph below. This is very simple, right? So now we have this graph. This is one part of the graph, okay? We call it what? It's a piece. Remember, piecewise. This is a piece or a segment. So we have one piece this way and have what? Another piece. In other words, this represents a function, this represents what? A function. So now, let me trace this, okay, to touch the y-axis, right? So if I trace it to touch this, what value do you have here? It's supposed to be 7. Is that also? Let's also trace this. If I trace this to touch here, it's supposed to be what? Negative what? 1. Why am I doing that? I'm doing this because I'm interested in the coordinates at that point. So at this point, what do we have? Look at, let's consider this. This is 2 and this is 6. So that means what will be here? Here will be what? Obviously, you have what? 4. So let's write out the coordinates. So the coordinate at this point will be what? On the x-axis, what do you have? You have 4. Then comma the y, this on the y-axis, what do you have? Negative 1. So I have negative 1. As simple as that. Now, let's come here. Here, what do we have here? On the x-axis. So let's say we have, okay, here, right? We have 4. Then on the x-axis, what do we have? Sorry, on the y-axis, what do we have here? We have what? 7. We have what? 7. So therefore, okay, the question didn't say we should write down the domain. Is that also? So let's write down the range. So the range will be what? The same analogy. Negative 1, right? Remember, we are interested in the y coordinates, right? So I have negative 1, then I have what? I have 7. As simple as that. Now here, so this one was the range, right? This is what? The domain. So here, determine the domain of a piecewise defined function. So f of x is given by this. Now, what would be the domain? This is very simple. Viewers, you can decide to graph this relation and graph this, right? Then now come and what? Account for the domain. What do I mean? As we did over here, what do we do? We have to graph this and that and look for the domain, right? But I told you that when you practice this for long, you can just do this one time, right? Good. So what do we do here? Let me give you a trick. Remember, for the domain, what are we interested in? We are interested in what? In the x values. But for range, we are interested in the y coordinates or the y values. So what do I have here? I have negative 4 and I have what? 8. So under normal circumstance, we are supposed to start from what? The negative numbers to what? To the positive numbers. So therefore, it's from negative 4 to what? To 8. And that will be the domain. As simple as that. So therefore, the domain, okay, this is given by, what do we have here? We we have from -4, this is -4, sorry, for here, okay, this is the trick, okay, this is the trick. Here, you have from -4 here, then you come and pick the last one. That's how it's supposed to be. So for the domain, you consider the first coordinate, okay, the first x coordinate, then now come and consider the last coordinate, okay. At first, I was trying to say you consider the x values, okay. You only do that when you have the graph. Take note. You only do that when you have what? When you have the graph, okay. So for instance, viewers, for instance here, for the range, I can consider this and that. Do you get it that way? Good. But for this one, what do? You have to consider this and that. And the domain will be what? This and that. But for situations like this, we are trying to adopt a fast way. Is that also as a result of that? We don't have to take this and that. You will be wrong. So what do? You pick the first one, which is what? Your -4, and your last coordinate, which is what? Your 9. You can draw for this and that when you find for your domain. The last question reads, determine the domain and range of the function f of x, okay, which is equal to the whole of that, right? Now, here we have x squared minus 36 all over the expression x minus 6. All right, good. In order to make this function define, we have to make sure the denominator should not be equal to 0. So I have x minus 6 should not be equal to 0. If it is equal to 0, the function will not be defined. In other words, the function will be what? Undefined. So let's make x a subject. We have x which is not equal to what? When you transpose this, we have what? +6. And that explains why you have what? This condition over there, right? Good. So therefore, or what it means is this. It means this function can assume all possible values for x. But remember, x shouldn't be equal to 6. Otherwise, it will render the function undefined. So if that is the case, remember we said what? Then belongs to all set of what? All sorts of rows, except what? 6. As simple as that. Now, the second one, we have what? A constant function, right? And this is the condition. If x is equal to 6, what it means is this. It means what? 6. So we are saying f of x which is equal to 12. If x is equal to 6, then which means the value, okay, which means it belongs to the values what? It belongs to the value 6. So the domain, how to write the domain for function like this? We have a constant function. If x is equal to a specific number which is equal to 6, then the domain is simply what? You open your curly bracket, you put 6 at that point. As simple as that. And now, the domain of the function of f of x is the union of the domain of this function to this function. So what it means is this. It means you are going to combine the domain of this function to this. So let's do the combination. So right now, so the domain of the function f of x is what? It's simply finding for the domain of this function, which is what? Which is this. So I have what? All sets of rows except what? 6. Right? Then union, we are combining this, so union what? Union the domain of this, which is what? Which is what? Your 6. And this is simply what? Your real number. As simple as that. Viewers, look for the range of the function for me and write down your answers in the comment section, right? But before that, let me just give you a hint. How do we find for the range of this function? Simply, this is what we are going to do. Under normal circumstances, we are supposed to graph this, right? And look for the end point Okay, in other words, let's do this. In other words, what I'm trying to say is you have to what? You have to evaluate this. So the range, to get the range, let's work for this separately. What do we have? We have x squared minus 36 over what? X minus 6. The numerator is what? It's an indication that you have a difference of 2 squares. So this is the same as what? X squared then minus 36 is the same as what? 6 squared over what? X minus 6. So this is what? Difference of 2 squared. What do? You add them in one bracket. You add the expression in one bracket. Then what? Then you subtract them in another bracket. Then all over what? X minus 6. So clearly, this cancels this. So this whole function, f of x, okay, becomes what? X plus 6. Do you get it that way? What do? Then you graph this. So when you graph this is simple. I said if you do this for long, you can just graph this off head. So if this is 5, this is 6, this is 7, 0, when you have your negative value, you have something like this. Yeah, something like this. Then open at this point, then you will now trace the corresponding what? Y coordinates, right? So this is what you can do in order to what? To get the range of the formula. So I think you should get something like this. Something like, is it 12 or so, right? So you have x axis, graph them, okay? And at this point, okay, look for the corresponding what? Y coordinates, right? Then you can now combine it with what? With the second one. And that will be what? The range of the formula f of x. Remember, the range of the formula is the range of this formula union the range of this. And the domain of this function is the domain of this function union the domain of this. You merging them together, that will be what? The overall range and the overall domain of the function given. Viewers, this is the end of the tutorials under range and domain of piecewise defined functions. So in these tutorials, we've learned on various ways and means to write down what? The domain and range. Okay, so you can be given what? The graph, and you can be asked to write down your range and your domain. At times too, you can what? You can be given what? The function itself, and you have to graph it in order to find for your range and your domain. And you have various ways you can write what? Your range and your domain. You can use what? You can use these open circles. Okay, so you have what? Your open bracket this way, and you have what? This is your open bracket, and you have what? Your closed bracket. To write your range and your domain. Or you can write them in statement form, or you can use the inequality statement. Okay, x is such that x is, let's say, less than or equal to 6. Those kind of stuff, right? And we also learned about these things. Okay, these are also new stuff. We also learned in this video. Just make sure you know what you're doing. Never stop learning and never stop practicing what you study. For those who stop learning, they stop living. I'll see you next time for wonderful videos. Bye.